All right, we're still in lesson 36. We're on 36b, the sums of trigonometric functions. It's a kind of a mouthful there. So I've got my reference triangles that I need to have handy, my 30, 60, 90, and my 45, 45, 90. And I'm going to look at my trigonometric functions. Let me just write them down here. I have SO, CA, and TOA. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So we just remind ourselves of that by having it handy. So let's add these together. First, I need to figure out where they live so I know what's positive and negative, right? So I'm just going to draw a little system here for this one. And I'm going to figure out where the angle 135 lives. So this is going to be my terminal side. This is a positive angle, so I'm measuring from the terminal side. So it's 90. And then 45 more would make this a 45-degree angle relative to the x-axis. So from here to here is 135. So this is going to be a 45, 45 angle reference triangle. So it means this is 1, and this is the square root of 2. Now, this is going to be negative because it's on the negative side of the x-axis. This is going to be positive because it's on the positive side of the y-axis. So now I know what the cosine of 135 degrees is. CA is adjacent over hypotenuse. And the adjacent side to a 45-degree angle is -1 over square root of 2 because this is a hypotenuse. Now my tangent is opposite over adjacent, but it's 330 degrees. So I know if I go, let me use a different color, all the way around to here, that's 270. Oh, that's not what I wanted it to do. 90, 180, 270, and another 60 degrees gets me to 330. So this is going to be my right angle. This is 30 degrees here, which means that here's my 30-degree reference and my 90-degree. This is going to be the square root of 3, and it's going to be positive. From here to here is going to be a -1 because it's on the negative side of the y-axis, and the hypotenuse is 2, and it's always positive. So the tan of 330, that is the opposite over the adjacent. So the opposite side is -1 over the adjacent side, which is the square root of 3. So there's my resolved cosine and tangent for those two degrees of measure. So now I can just get rid of the radical sign in the denominator and try to simplify it as much as possible. So that's what we're going to do. So -1 over square root of 2 times square root of 2 over square root of 2 plus -1 over square root of 3 times square root of 3 over square root of 3. That's going to give me a -1 times square root of 2 over 2 plus a -1 times square root of 3 over 3. Now I just resolve to have a common denominator, and I get -3 times the square root of 2 over 6 plus -2 times the square root of 3 over 6. Now because they have the same common denominator, and because they're both complex numbers, both having a radical variable, I can put them together into one fraction. So -3 times the square root of 2 minus 2 times the square root of 3 all over 6. And that would be my answer for this one. And I'm going to move it out of the way so it doesn't infringe on this problem here. All right, so let's look at the next problem and review it. All right, so I have, let's do, give me another little coordinate system here. and let's evaluate where this lives. All right, this is a negative 60. So that means I'm going to measure from the initial side 60 degrees. So that was actually pretty straightforward and easy. Now I'm just going to look at my reference triangle. That would mean this is a 90-degree angle. So from the 60 to the 90, that's going to be a 1. And the hypotenuse is 2. And from the 30 to the 90 is the square root of 3. So this is going to be a negative square root of 3 because it's on the negative side of the y-axis. All right, so cosine means adjacent over hypotenuse. So the adjacent side is 1 and the hypotenuse negative square root of 3. No, it's not. It's not the hypotenuse. So that is ka. That's what cosine is ka. So that's hypotenuse is 2. So it's going to be 2 right there. All right, plus cosine of 210. So all I have to do is let's use a different color. And it's a positive degree. So I'm going to measure from the terminal side. That's 90, 180. And then to go from 180 to 210, that's going to be another 30 degrees. So I have a 30-degree triangle here. This is 30. So that means that this is the square root of 3, this is 1, and this is 2. Now this is going to be negative, and this is going to be negative because this is on the negative side of the x-axis and the negative side of the y-axis. So we know that a negative over a negative is going to be a positive, right? So that would be, oh, I'm sorry, positive. It's the hypotenuse, not the adjacent, or the opposite. So adjacent over the hypotenuse. So that's going to be a negative square root of 3 over 2. And because both of these are the same denominator, I can just say 1 minus the square root of 3 over 2. And I'm done with that one. That is the answer. All right, so let's look at number 36.3. So I've got another little coordinate system here to kind of figure out where these angles live. And notice these are greater than 360. All right, so I need to figure out exactly where this is. So I'm going to subtract, because it's positive, I'm going to subtract 360. So 570 minus 360 is going to be 210 degrees. So that is going to be 90, 180, and another 30 degrees here to get to 210. So this is going to be a negative square root of 3, a negative 1, and a positive 2. And I'm looking for the cosine. So that is going to be ka. So adjacent, which is a negative square root of 3, over hypotenuse, which is 2. Now let's look at the sine of negative 765. Now that is an over rotation as well. But because it's negative, I am going to add 360. So plus 360, that gives me 5, 0, negative 4. It's still greater than 360. So I'm going to add another 360 to it, see what I can get from there. So this is going to be 5. And this is going to be 4. Negative 45 degrees. So because it's a negative 45 degrees, I finally have a degree of measure that is less than 360. I'm going to, let me use the blue for this one. I'm going to start on my initial side and measure in 45 degrees. Okay, so this is 45, which means this is 1, this is 1, this is going to be a negative 1, and then this is going to be square root of 2, and it's always positive. So plus the sine is so it's opposite over hypotenuse. So the opposite side is negative. So this is going to be negative 1 over square root of 2. So now I need to get rid of my denominator that has a square root in it. So negative square root of 3 over 2 plus negative 1 over square root of 2 times square root of 2 over square root of 2. Negative 3 plus a negative 1 times the square root of 2. This could be over 2, and this is going to be over 2. So that means because they have the same denominator that I can resolve them into one fraction. So it's going to be negative 3 minus the square root of 2 all over 2. And let's see if, yes, the book agrees. All right, so you see how easy that is. Having your reference triangles handy is going to make it a lot easier on you to do this with mental math, and which is the whole point. You want to understand how and why that this works. Okay? So seeing this, seeing how all this is set up, that's going to help a lot. And that's all we have for 36B, sums of trigonometric functions. We have one more section, it's 36C. We're going to do some boat in the river problem. So I'll see you after we do a few practice problems for this.